In this video, we're going to cover the actual practice questions that AWS offers for the Certified Developer Associate exam. The questions that AWS offers tend to be multi-service and a lot more multifaceted. So far, we've covered quizzes that address one AWS service at a time. Practicing these questions together is going to be a great way to start to see how AWS wants you to think for the exam. So let's get started. Number 1. Your CloudFormation template launches a two-tier web application in US East 1. When you attempt to create a development stack in US West 1, the process fails. What could be the problem? Is it A, the AMIs referenced in the template are not available in US West 1? B, the IAM roles referenced in the template are not valid in US West 1? C, two ELB classic load balancers cannot have the same name tag? Or D, CloudFormation templates can be launched only in a single region? Feel free to take a moment to think about this question. And the best answer here is A, the AMIs referenced in the template are not available in US West 1. Now recall from our module on EC2 that AMIs are specific to particular regions. AMIs are stored in a region and cannot be accessed in other regions. To use the AMI in another region, you have to copy it to that region. IAM roles are valid across the entire account. C, two ELB classic load balancers cannot have the same name tag, is not really an applicable answer here. And of course, D, CloudFormation templates can only be launched in a single region, is absolutely not the case. You can launch a CloudFormation template in any region. It's just that if you're using a region-specific resource like AMIs, you might have to tweak it a bit. Number 2, your application reads commands from an SQS queue and sends them to web services hosted by your partners. When a partner's endpoint goes down, your application continually returns their commands to the queue. The repeated attempts to deliver these commands use up resources. Commands that can't be delivered must not be lost. How can you accommodate the partner's broken web services without wasting your resources? A, create a delay queue and set delay seconds to 30 seconds. B, re-queue the message with a visibility timeout of 30 seconds. C, create a dead letter queue and set the maximum receives to 3. Or D, re-queue the message with a delay seconds of 30 seconds. And the answer here is C, create a dead letter queue and set the maximum receives to 3. After a message is taken from the queue and returned for the maximum number of retries, it is automatically sent to a dead letter queue if one has been configured. It stays there until you retrieve it for forensic purposes. So if you're worried about lost resources and these can't be lost, then setting up a dead letter queue is a great fallback. Number 3. Your application must write to an SQS queue. Your corporate security policies require that AWS credentials are always encrypted and are rotated at least once a week. How can you securely provide credentials that allow your application to write to the queue? Is it A, have the application fetch an access key from Amazon S3 bucket at runtime? B, launch the application's Amazon EC2 instance with an IAM role? C, encrypt an access key in the application source code? Or D, enroll the instance in an Active Directory domain and use AD authentication? And of course the answer to this one is B, launch the application's Amazon EC2 instance with an IAM role. The reason for that is if you use an IAM role, a service role with EC2, then you don't have to manage any of those credentials. It can't be A because you need a key to be able to fetch a key from the bucket. It's certainly not C because storing your access key in your source code is not a secure way to store credentials. And it's not D because Active Directory authorization won't grant access to AWS resources. Number 4. Which operation could return temporarily inconsistent results? A, getting an object from Amazon S3 after it was initially created. B, selecting a row from an Amazon RDS database after it was inserted. C, selecting a row from an Amazon RDS database after it was deleted. Or D, getting an object from Amazon S3 after it was deleted. And the answer to this one is D, getting an object from Amazon S3 after it was deleted. Let's recall the consistency rules that we know about S3. We know that for overwrite puts and deletes, Amazon S3 offers eventual consistency. So if your application were to try to get an object immediately after it was deleted, it could temporarily still return that option. Number 5. You are creating a DynamoDB table with the following attributes: purchase order number, which is your partition key, customer ID, purchase date, and total purchase value. One of your applications must retrieve items from the table to calculate the total value of purchases for a particular customer over a date range. What secondary index do you need to add to the table? Is it A, local secondary index with a partition key of customer ID and sort key of purchase date, project the total purchase value attribute? B, local secondary index with a partition key of purchase date and sort key of customer ID, and project the total purchase value attribute? C, global secondary index with a partition key of customer ID and sort key of purchase date? Or D, global secondary index with a partition key of purchase date and sort key of customer ID? And the answer to this one is C, global secondary index with a partition key of customer ID and sort key of purchase date. The query is for a particular customer ID, so a global secondary index is needed for a different partition key. To retrieve only the desired date range, the purchase date must be the sort key. Projecting the total purchase value into the index provides all the data needed to satisfy the use case. Number 6. Your CloudFormation template has the following mappings section. Which JSON snippet will result in a particular AMI value when a stack is launched in US East 1? And the answer to this one is C. We can automatically eliminate A and B because when you're looking for something in a mapping in CloudFormation template, you're never actually going to look in the mappings resource. That covers all resources inside mappings, so it's not A or B. We can rule out D because if you tried to traverse mappings using D's syntax, you wouldn't get anywhere. So of course the answer is C. We're going to traverse region map, and then the particular region, and then 32. Number 7. Your web application reads an item from your DynamoDB table, changes an attribute, and then writes the item back to the table. You need to ensure that one process doesn't overwrite a simultaneous change from another process. How can you ensure concurrency? Is it A, implement optimistic concurrency by using a conditional write? B, implement pessimistic concurrency by using a conditional write? C, implement optimistic concurrency by locking the item upon read? Or D, implement pessimistic concurrency by locking the item upon read? And the answer here is A, implement optimistic concurrency by using a conditional write. Optimistic concurrency depends on checking a value upon save to ensure that it is not changed. Pessimistic concurrency prevents a value from changing by locking the item or row in the database. DynamoDB does not support item locking, and conditional writes are perfect for implementing optimistic concurrency. Number 8. Your application triggers events that must be delivered to all your partners. The exact partner list is constantly changing. Some partners run a highly available endpoint, and other partners' endpoints are online only a few hours each night. Your application is mission critical, and communication with your partners must not introduce delay in its operation. A delay in delivering the event to one partner cannot delay delivery to other partners. What is an appropriate way to code this? Is it A, implement an Amazon simple workflow task to deliver the message to each partner, initiate an Amazon simple workflow execution? B, send the event as an Amazon SNS message, instruct your partners to create an HTTP, subscribe their HTTP endpoint to the Amazon SNS topic? C, create one SQS queue per partner, and iterate through the queues and write the event to each one. Partners retrieve messages from their queue. Or D, send the event as an Amazon SNS message, create one SQS queue per partner that subscribes to the Amazon SNS topic, and partners retrieve messages from their queue. And the answer here is D. There are two challenges here. The command must be fanned out to a variable pool of partners, and your app must be decoupled from the partners because they are not highly available. Sending the command as an SNS message achieves the fan out via its publication subscribe model, and using an SQS queue for each partner decouples your app from the partners. Writing the message to each queue directly would cause more latency for your app and would require your app to monitor which partners were active. It would be difficult to write an Amazon SWF workflow for a rapidly changing set of partners. Number 9. You have reached your account limit for the number of CloudFormation stacks in a region. How do you increase your limit? A. Use the AWS command line interface. B. Send an email to limits@amazon.com with the subject CloudFormation. C. Use the support center in the AWS Management Console. Or D. All service limits are fixed and cannot be increased. And the answer, of course, here is C. Use the support center in the AWS Management Console. Now, we know from previous videos that if you need to request any service increase for your account, the way to do that is through the support center. And finally, 10. You have a 3-tier web application, which includes web, app, and data in a single Amazon VPC. The web and app tiers each span 2 availability zones, are in separate subnets, and sit behind ELB Classic load balancers. The data tier is a multi-availability zone Amazon RDS MySQL database instance in database subnets. When you call the database tier from your app tier instances, you receive a timeout error. What could be causing this? Is it A, the IAM role associated with the app tier instances that does not have rights to the MySQL database? B, the security group for the Amazon RDS instance does not allow traffic on port 3306 from the app instances? C, the Amazon RDS database instance does not have a public IP address? Or D, there is no route defined between the app tier and the database tier in Amazon VPC? And the answer, of course, here is B. The security group for the Amazon RDS instance does not allow traffic on port 3306 from the app instances. Now, having your security groups not set correctly can absolutely lead to timeouts, but the answer can't be A because MySQL instances are covered by MySQL security, not IAM security. It's not C because resources in a VPC don't need public IP addresses to talk to each other. And it's not D because all subnets in a VPC have default routes to all other subnets in a VPC. And that covers it for the AWS provided sample questions for the Certified Developer exam. If any of that didn't make sense, I definitely encourage you to go back and review some of the videos. And if all of that did make sense, then feel free to move on.